More electronic devices are making the transition to USB Type-C, and as electronic devices increasingly require more power, USB Type-C with power delivery, or PD, is becoming an important topic. However, the complexity of designing USB Type-C with power delivery often discourages system designers from making the transition. Hi, my name is George Harriman, and I am a systems architect with ROHM Semiconductor. Today, I will be presenting a few of our USB Type-C and USB Type-C power delivery standalone controller products that do not require any control by an external MCU, thus making the process of switching over much simpler. The vision of the future is that USB Type-C cable will not only deliver data and video, but also up to 100 watts of power over the same cable. It is intended to further declutter our electronic connections by only having one electronic device be connected to the wall adapter. In the example above, it is the TV, while all other electronic devices will be powered from the TV via USB Type-C and USB Type-C power delivery cables. More and more electronic devices have started the switch to USB Type-C, and this presentation is intended to help system designers to understand some benefits of ROHM's solution. ROHM provides various solutions to products applicable to USB Type-C, power delivery, or PD compatible devices. This document will introduce the BD93F10MWV, BD93E11GWL, and the BD91N01NUX for power sync or power charging devices. These products are standalone and does not need any control by an external MCU, making them easy to use. The block diagram above shows where these three products are used in the overall system of a sync-type electronic device. The main target and application of the three products that are explained in this presentation is shown above. It is mainly for applications that require no data or non-communication devices, and UFP or upward facing port or peripheral devices in terms of data role. While for power role, it is the sync type of devices, which mean they are for devices that require power charging. Examples shown include small portable electronic devices such as wireless headphones, drones, as well as small point-of-sale or POS printers and speakers, as well as certain portable cameras and video recorders. ROHM's product offer reduction in both cost and also workload. Cost reduction is achieved by eliminating external protection devices, as all three products have their own internal protection and high voltage withstanding features. Workload reduction refers to the reduction on the end customer side during system development and design stage. All the products that will be shown here are standalone, meaning they do not require any control by an MCU. Configuration of our parts are done via external GPIO pins via resistors, which is only done one time. No firmware is needed for our parts as they come preloaded with all necessary functions. Furthermore, the end customer engineers do not necessarily need to be familiar with the many USB standards, as ROHM's products are fully compliant and handle all the necessary USB-C power delivery communication. Each product that are represented here not only have a data sheet, but each of them also have other supporting tools and documents. For example, installation guides, application notes, evaluation boards or kits, as well as the associated quick start guides are available on their respective websites. These are provided to further ease the design and development cycle for end customers. The next few slides will explain about ROHM's BD91N01NUX USB-C detector protection device. BD91N01NUX is mainly targeted towards applications that only require USB Type-C but not full power delivery capabilities. This means that it is targeted towards only supplying 5-volt supply, migrating from an older USB Micro B 5 volts 1.5 amps or 7.5 watts to USB Type-C 5 volts 3 amps or 15 watts. Some recommended applications shown are portable electronic equipments such as wearable audio devices, wearable watches, fitness bands, point-of-sale terminal, and certain cameras and video recorders. The block diagram above shows the easy transition between existing USB Micro B solutions towards the new USB Type-C solutions. BT91N01NUX features a built-in switch or FET driver to drive an external PMOS FET. The external PMOS FET will only be turned on after BT91N01NUX determines that the signals on CC lines are stable and valid. It also features 28-volt withstand voltage on both CC1 and CC2 pins as well as the V-bus pin. 4 output pins can be connected to host controller to detect: first, USB Type-C plug orientation, which is important for USB 3.0. Second, detection of external FET driver status. It is important to know that the CC lines are stable and the V-bus is within range. Third, as well as 2 TCC status output pins that give indication of USB Type-C current detection or power capability of the USB Type-C plug that it is being connected to. It is important for downstream systems to make power setting determination. BD91N01NUX comes in a space savings SON 10-pin package measuring only 3 mm by 2 mm. Its small space-saving package size is suitable to area-constrained designs. The product can also operate from dead battery condition, requiring only power supplied from the USB Type-C V-bus line to operate. Further, V-bus over voltage protection or OVP function gives safe operation features. When compared to some other vendors' solution, ROHM's BD91N01NUX has many advantages, such as CC pin able to withstand up to 28 volts, built-in switch or SW external FET driver, over voltage protection or OVP on V-bus, able to operate from dead battery condition, and not needing any external configuration and making it truly a standalone operation. Evaluation boards or EVKs are available to purchase on various distribution websites. Easily evaluate BD91N01NUX and connect your existing system to USB Type-C connectors by using our evaluation boards. The next few slides will explain about ROHM's BD93F10MWV and BD93E11GWL standalone sync USB-C power delivery or PD controller devices. BD93F10MWV is mainly targeted for applications that require more than 15 watts delivered on the USB cable. In order to achieve this, compliance to USB Type-C with power delivery is required. Similarly, older systems that depend on a dedicated DC input plug or connector can now be replaced with a USB Type-C or power delivery cable. BD93F10MWV is standalone operation that does not require any control from an external MCU, making operation simple for system designers. Some recommended applications shown are portable electronic equipment, such as external hard disk drive or HDD, point-of-sale terminals, drones, portable battery-powered speakers, and certain cameras and video recorders. The block diagram above shows the easy transition between existing USB Micro B solution towards the new USB Type-C solution. Further miniaturization can be achieved by selecting the BD93E11GWL version, which comes in a space-saving wafer-level chip-scale packaging or WLCSP. Some recommendation applications shown are portable electronic equipment such as point-of-sale terminals, drones, and certain cameras and video recorders. Both BD93F10MWV and BD93E11GWL comes with built-in external switch or back-to-back anti-parallel FET to control the power delivery path. Back-to-back FET offer reverse current protection of the USB Type-C connector and the internal system circuitry. External GPIO pins are used with external resistor dividers, which is a one-time setup, to configure the parts' Vmin, Vmax, and Pmin settings appropriately for power delivery negotiation with a charger device. Settings range from Vmin, Vmax of 5 volts with Pmin of 0.5 watts up to Vmin, Vmax of 20 volts with Pmin of 80 watts. There is no need for any firmware to be programmed or modified. All features and function is already built in and complies with USB Type-C power delivery standards. BD93F10MWV comes in a QFN 40-pin package measuring 5mm by 5mm. It features many built-in protection and safety functionality, such as current sensing to detect overcurrent protection or OCP and short circuit protection or SCP, external thermistor detection to sense over temperature or TSD, internal thermal shutdown protections or OTP, and V-bus overvoltage protection or OVP. BD93F10MWV is standalone operation that does not require any control from an external MCU, making operation simple for system designers. BD93E11GWL comes in a space savings CSP 36-pin package measuring only 2.63 mm by 2.63 mm. When compared to some other vendors' solution, ROHM's BD93F10MWV and BD93E11GWL has many advantages, such as CC pin able to withstand up to 28 volts on the BD93F10MWV version, built-in switch or SW, external back-to-back one-path NMOS FET driver, overvoltage protection or OVP on V-bus, overcurrent protection or OCP on V-bus, CC pin short circuit protection or SCP, thermal shutdown external thermistor sensing circuitry, not needing any external configuration and making it truly standalone operation. And lastly, very small package of only 2.63 mm by 2.63 mm on the BD93E11GWL version. Evaluation boards or EVKs are available to purchase on various distribution websites. Easily evaluate BD93F10MWV and BD93E11GWL and connect your existing system to USB Type-C connectors by using our evaluation boards. Thank you for your time. Please visit our website and consider evaluating the products mentioned in this presentation by checking out our evaluation boards.